Hi everyone, welcome back to another daily video where we go over solutions to interesting math problems. And today we'll be looking at problem number 22 from the 2020 AMC 8. And let's get started by reading the question. Okay, so we have a little function problem where it says that any positive integer n is fed into a machine and the output is a number calculated according to the rule shown below. And the rule is basically if n is an even number, then you output n divided by 2. And if n is odd, then your output is 3 times n plus 1. So just to make sure we understand this, they give us an example. So if we start with n equals 7, then because n is odd, we do 3 times 7 plus 1 to get our output of 22. And then if we keep inserting this, our output to get a new output, we would get the following sequence. So we have 7, 22, then 22 is even, so we divide that by 2 and we get 11. Now if we plug 11 back in, 11 is odd, so we want to multiply by 3 and add 1, which would give us 34. Now again, 34 is odd, so we want to go, 34 is even, sorry. So then we want to do 34 divided by 2. And then 17 is odd, so we multiply by 3, add 1 to get 52. And then lastly, 52 is even, so we simply divide by 2 and get 26. So now the question is, if we were to apply the same 6-step process to some random starting value n, our final output is 1. And they're asking us for the sum of all possible values of n. Okay, so here, this is a problem number 22, which it tells us it's at the end of the test. It's likely going to be a bit more challenging, and so it's okay if we spend a little more time on this. And so with these type of questions, while we could start from n and then kind of take cases, it's too hard to kind of guess if n is even or odd because we get a different output each time. So for something like this, I actually prefer to move backwards. So we know our output is 1. So if we kind of work backwards and say we have 1 would be our final output. So if we get 1 as our final, we kind of want to figure out what did we plug in to get 1 as an output. So to kind of find this, we want to basically do n divided by 2 equals 1 or 3n plus 1 equals 1. So if we kind of solve the first equation, n divided by 2 equals 1, we simply get n equals 2. So 2 is a possible value. And if we do 3n plus 1 equals 1, we would get n equals 0. And while this does seem to work, the only thing is n equals 0 is even. So if I were to plug in n equals 0, I would just get an output of 0 divided by 2 and not 3 times 0 plus 1. So this would actually be kind of like an extraneous solution. So this just tells us when we plug in 2, our output is 1. And 2 is the only number that we can plug in to get 1 as an output. Now we do the same thing. So we want to figure out what comes before 2. So again, we have two cases. Either we do n divided by 2 equals 2, or we have 3n plus 1 equals 2. Now, the first equation, our solution is n equals 4. So we get n equals 4. And now for the second equation, we would get 3n equals 1, but there is actually no solution to this because it says that n has to be integers. It's a positive integer, right? So this does not work. Okay, so this is kind of the process that we're going to follow. Okay, so if we make some more space. So we have, now from 4, we can, so let's just write this again. 1 goes to 2, goes to 4. So now from 4, we have, again, we do the same process. We get n over 2 equals 4, or we get 3n plus 1 equals 4. But now, see, we have this always works. N divided by 2 equals 4, so n equals 8. But our second solution is also viable here because we get n equals 1 is the solution to this equation. So this means that when we plug in 8 or 1, we get an output of 4. So now we have our tree kind of splits. So we continue this 8 path, but we also have to go back and do the when n equals 1. If I kind of make some more space here. So we could start with the 8, right? So with 8, if we're trying to figure out the outputs, so we have, if we work up here, n divided by 2 equals 8, or 3n plus 1 equals 8. So n equals 16 is a solution. Or if we do this, we see we get 3n equals 7. And because 7 is not divisible by 3, this we don't worry about. So when we get 8, it's just 16. And now the interesting thing is, if we go back and do this 1 right here, the thing is, we already started with a 1. So we know that the output here, to get a 1, we just have to plug in a 2, right? Because when we started with the 1 right here, the only possible input to give us a 1 is the 2. And the same thing holds here. So now we continue working. And again, the 2, let's start with the 2 this time. We already did the 2 example, right? To get an output of 2, the only possible input would be a 4. So we could write down our 4. Now if we go back to the 16, so we have n divided by 2 equals 16, or 3n plus 1 equals 16. So now the first equation, we get n equals 32. And then the second equation here also works because we have 3n equals 5, which means, or 3n equals 15, which means n equals 5. So that means 16, to get an output of 16, we could either plug in a 32 or we could plug in a 5. And so now if we quickly go back to the problem and check what they're asking for, the question's saying, what's the sum of all possible integers n when we apply this process 6 times? And to check how many times we've actually done this so far, we just count the number of arrows we have, right? So we have our first arrow, let's do it right. Our first arrow is right here. Our second is right there. And these are third step. This is the fourth step. And then this would be our fifth step. So that means we just have to do one more iteration of this function, and we should get our final values. So let's just start with 32. So we have n divided by 2 equals 32, or 3n plus 1 equals 32. This means n equals 64 is a possible solution. And if we do 3n plus 1 equals 32, that would be 3n equals 31. And we know 31 is not divisible by 3. So this we kind of ignore. So that means 64, when we plug in 64 and we perform this process 6 times, we go all the way down to 1. So this will be one of our kind of final answers. Now if we plug in 5, we have n divided by 2 equals 5, or 3n plus 1 equals 5. And again, the first equation gives us n equals 10, so we can write that down. And the second equation has no solutions because 3n equals 4 has no solutions in the integers. So 10 is our next solution. And now 4, we could do the same process, but if you recall, we already looked at 4 up here at the start of our chain, and 4 produces either an 8 or a 1, right? So 4 goes either to an 8 or to 1. So we can just write that down, save some time. And we know that to get a 4, we either plug in 8 or 1. So now the question asked us for the sum of all these integers that would lead to 1 after we apply the function 6 times. And we've shown that these are the 4 numbers. So we just want to add 64, 10, 8, and 1. And that would come out to 83. And this would be our final answer. So we circle this and move on. So the moral of this story is the problem definitely seemed a lot longer, a lot more complicated than you might be used to. But if you kind of take it one step at a time and maybe working backwards in some cases, it's a lot easier than working forwards. And the other thing is, for a question like this, if you have some leftover time and you want to check this, these type of problems are very easy to check your work because all you have to do is plug in these 4 numbers we got, 64, 10, 8, and 1. And then if you get an output of 1 after performing the function 6 times, then you know you should be in a good spot. So that should be all for this problem. Thank you for watching, and if you enjoyed the video, make sure to drop a like, a comment, or subscribe so you don't miss any future uploads. So thanks to everyone for joining, and be sure to join the next session.